Hello again. So we only really do data analysis when we have a large set of data. I mean, maybe I shouldn't say large. I'm not talking about, capital B big data. But like if I'm teaching an independent study with two students in it, and I want to know how the students did on the midterm project, I mean, I go to my grade book and I see that one of them got an A and one of them got a B, and I say that they did pretty well. I mean, there's not a lot of additional analysis that it really makes sense to do in that context. Whereas if I have a class of 20 students, it might not make so much sense to just look at all the grades individually. It might make more sense to compute a mean or compute a median or something like that. And from the point of view of the data types we saw in the last video, that sounds like a problem because the data types we saw in the last video store single values. Like I can have a test variable, but it stores a single test grade. It doesn't store the entire class's test grade. So in this and the next video, we'll learn about higher dimensional data types that can store more data. And perhaps the advantage of this is intuitively clear and doesn't really need an explanation or a demonstration, but let's demonstrate it nevertheless. Say that our goal is to take student test scores and compute the average. Well, if we were going to do this using the tools of the previous video, we would have to have an individual variable for every student in the class. And now that I have these, I can compute the average, but computing the average is going to be also quite tedious. I won't subject it to you in full, but we take all of these variables and we add them together and we divide by 6. And of course, even with this very, small data set, that was not so thrilling to do by hand. If I were at a big university and, I had 70 people in an intro class, it would be even less thrilling. So, I mean, the problem here is that the average is really, you take the average of a set of data. And here we don't properly have a set of data. We have a bunch of individual values. So vectors provide us a way around this. They're one of the fundamental data types of R, not in like a formal programming sense. In that sense, they're not fundamental. They're built up from other data types, but in a we use them all the time sense. So a vector is, I mean, we can think of it as being a list of values. And I have the word list in quotation marks here because there's a different data type called a list. So it's a little confusing, but I mean, just in everyday English, this does describe what a vector vector is. Like we can take these scores and we can make a list of these 6 scores and call it a vector. I guess that the terminology is a bit unfortunate. Let me say now, I'll come back to this later, that the values all have to have the same data type. So the way we create a vector, I mean, it's like any other variable. We give it a name, say test underscore scores, and we assign it using the usual assignment operator. Then we write C and open parentheses, and in the open parentheses, we list the things we want to be in the vector separated by commas. So 98, 87, 78, 88, 92, 34. And now we have created test scores. Nothing shows because the assignment operator doesn't have a visual output. But if I type the variable name, we can display it. And once you have a vector, things like computing means and medians and standard deviations, things like graphing data, or the stuff that's most naturally done on a set of values rather than on individual values, becomes a heck of a lot easier. If I want to compute the mean now, I type mean, and then in parentheses, I put test scores, and it comes out real nice. Let me see. I was going to say that this syntax, I mean, this function notation, if you've ever taken a math class before, we'll talk about more in its own video and its own Canvas page. So I say that vectors can only store a single data type. Um, I've also said that there are multiple numerical data types, but that's not usually going to cause a problem. And here is an example of how it won't cause a problem. If I change the 34 to 34.6, I now have multiple data types here. I will probably call these ints and floats until the day I die. But under the hood in R, this is the int data type, and the 34.6 is the numerical data type. So this is not going to cause problems. If I view test scores, you see it's just taken all of these ints, all of these non-decimals, and it's turned them all to decimals. And then we can do stuff like find the mean, no problem. But what if I add to this list the string hasn't taken? What do you suppose will happen here? Let me actually just compile the code. So we see it hasn't given us an error message, But if we view test scores, now all these numbers have been converted to strings. And this is something you have to be aware of. It's actually something that comes up surprisingly commonly. Like if I ever want to use R to do analysis on a Canvas gradebook, when you export the gradebook, the first row of every column contains a string. It contains the same string. I don't know why, but that means when you export a Canvas gradebook and then import it into R, everything is going to be a string. And that's not fatal. You can do conversions. You can convert the strings back to numerals, but it's something to be aware of. And like, let's see if I can. Let's take this test scores. Let's define test underscore scores underscore taken. And let's let that be test scores, but 1, 2, 3, 4, 5, 6, 7. But we'll delete the seventh element. Now we have this new variable. But if we try to define the mean of test scores taken, you can probably guess that we're going to get an error message because you don't find the means of strings. What's the mean of two words? That doesn't make any sense. You find the means of numbers. And we do indeed, not a formal error. It does run, but it gives us a warning, and the output is NA, not a number. Since I mentioned the idea of conversion, I might as well do it. Let's go back to when I defined test scores taken. I defined it to be test scores except for the item in the seventh place. If I wrap that in as numeric, it will hopefully, take those strings of numbers and convert them to real numbers. And now we can do stuff like find the median. So that's our introduction to vectors. In the Canvas page, there's more stuff. There's like, how do you replace an element of a vector? How do you find the length of a vector? Common things you'd want to do. I don't want to overload the video with things like that, just because in practice, I don't think it's very helpful to students. I think that if a student, needs to be reminded of how to find the length of a vector, they might Google how find length vector in R. They might go to the Canvas page and look for the function there. I don't think they're going to go to a video and try to fast forward to it and find, that function in a video. So for that reason, I'm going to try to keep these videos a little conceptual rather than get into that sort of nitty-gritty detail. And we will call it here for now.